Okay, no good at build montages, but this is another battery walkthrough. I got some batteries, I'm undoing some batteries and loading them into this case. And I have two more to go in this box, but I just wanted to give a little bit of a tour because once I put the last two in, kind of the cool looking stuff will be covered up. I have to put the extrusion on that's going to hold them firmly in place, but for now I've got four of them connected and I've got the insulation in on both sides and underneath of the concrete board, and also in here, this little gap, it's hard to see. So these are 5 kilowatt hours. This is going to be 30 kilowatt hours total with all 6, and it's forkliftable, sit outside, ready. Put it wherever you need the power and use it. It's set up to have two 200 amp outputs. So that looks like this. So it's 2 circuit breakers and then 2 circuits. So 2 200 amp circuits. I have 2 8 kilowatt inverters that I'm going to run with this simultaneously. So it'll be 1 circuit per inverter. I've had a hard time finding a lot of hardware over, once you get into like the 4 or 5 or 600 amp range, everything starts to get really hard to get and expensive. So I wanted to just keep it in multiples of lower current instead of one big giant connection. So this is going to be the battery cable. This is a 2-aught, which is a little bigger than I need for what I'm doing. It's type W mining cable. It's pretty rugged stuff. I don't necessarily recommend you buy this or anything. This is 2000 volt wire. So you could find something much more affordable than that. But that's what I got. And I've got 4 50 style DINS connectors and 2 200 amp circuit breakers. Please love your firefighters. If you're going to have something like this, have shutoffs on the outside and label it for what's in it very specifically so they can call the emergency number if something goes wrong, and they can get advice on how to handle it very specifically. This is lithium iron phosphate, so be sure that you label it as such for them. So here I put in a little power distribution block, and all of the batteries have equal length connectors or conductors again, and they all come to this terminus and they're combined in this block. And then I have 2 parallel outputs that go to 2 200 amp fuses, and this is a class D fuse, and then those go to these circuit breakers right here, and then the output of the circuit breakers go to the outputs that leave the case. So yeah, like I said, each whip here is the same length. Still have to make these 2 black ones, but yeah, so that's the build. There's nothing inherently combustible in this case. This is 105 degrees C cable, 600 volts. These are all Bakelite. These are Bakelite as well. And this mineral wool is not combustible. Concrete board is not combustible. These steel cans are not combustible, and this steel can is not combustible. So there's a lot of energy in a box like this, and if something goes wrong, whoever responds is just going to watch it burn. So it would be really great if they can disconnect it from the outside safely without even opening it. If they do open it, they can cut all the cables off of the different batteries and access it very safely if there was some sort of thing going on. So yeah, I like these batteries a lot. I just got them from those guys, and they've been nice guys to work with, and I did some troubleshooting with them, and it worked pretty well. So I was happy with that, and I got these new batteries, and I'm pretty happy with them too. So yeah, that's the build, and just put some stuff in there, did some rivets and some screws. I didn't put any adhesive or sealant on these because I'm afraid that they'll go bad and I'll have to take them out, and I'll regret having spooged them in. So I left those dry, and I put them in with easy to get out fasteners, so I can swap those if they need be. And a little less conveniently, these fuses would require some, you got to take this last battery out if you had to change the fuses. So if the fuses blow in the middle of the night, you're not going to be changing those. So yeah, that's the 30 kilowatt hour build. I've got some 450 watt panels I'm going to put on here. I don't know, maybe 25 of them or something. 24, I mean, of course, multiples of even numbers. I've got 3 classic 250 charge controllers I might put on there. I've been playing with the numbers. The biggest limitation for charging on this is the breakers and the fuses running back from the chargers. And the way I'm probably going to do it, I'm going to charge them on one set. So that limits me to about 200 amps of charging. So if I did more than 3 charge controllers at 55 amps each, it could be conceivable that I could overcurrent one of these circuit breaker situations here. And that would be, less great if I had nuisance tripping of the breaker, and a lot worse if I had blown those fuses. I really think those should be 300 amp fuses, because you really don't want those to go first. So I'll see how this goes, and if I have to change them for 300, I will do that. But the thought I had was 200 is the wrong number for that. Each of these has a capacity of 100 amps each. And so even if those were 300 amp fuses, that would still be sized properly for 6 of these batteries. So, yeah. Anyway, I'll think about that, and I'll change them if it's a problem. So yeah, that's another build. Thanks. Bye-bye.